Okay, we are back live. Morning. A whole bunch of work to do today. Maybe I should do maybe I should do a quick little overview just to get my thoughts clear cuz I've been thinking about this pretty much nonstop. Um so there's all this off-policy literature, right, that's built around sample efficiency, and there's on-policy literature that's built around compute speed, compute efficiency. Um and the thing that's difficult to say is whether you can make the off policy methods actually work in the high data regime well or not. That's the thing that's tricky. So I'm trying to bring these two together in a way that you can kind of do both. Welcome. Night in Vietnam. I've never been to Vietnam. I do know that you guys have good food there. One off pol. I'm gonna try one small change, I think, before I Okay, so at least in this setup, this doesn't make a difference, seems. Just makes it slower. Of course, it's like now we have a very aggressively tuned baseline. I try the on policy baseline, right? We have this super aggressively tuned baseline where we literally have the fastest training in the world on this. Kind of ridiculous to see, frankly. If I do, I just cut the number of environments in half, right? What happens? Welcome, Dinesh. Yeah, so here's the problem, right? Because the baseline is so aggressively tuned, this actually is going to do worse. The whole problem with RL research in a nutshell, right? The batch size gets smaller. The mini batch size doesn't, though, actually. So why do we think that this gets worse? It should be better, shouldn't it? You reduce your number of environments. Gotta just be something weird with the hypers, no? Okay, like if we think of it that way, actually, you know what? I have a question. I have a question that I want answered. Let's see how fiddly RL is. When we just don't have. Let's see, like, basically what happens to reinforcement learning with our current algorithm if we go to unoptimized dummy hyperparameters. I want to get a sense of that problem. Yes. Where they have their hypers. I just want to see what happens if we do this. Like, what happens if we basically... So this is how most RL research is done these days, right? Is people will just use, like, defaults. I mean, look at, like, it actually does do reasonably well. It's a huge difference, right? So at least we have stuff that's stable enough that we can do that and have it not break. I'm back. Welcome, Rishi. Okay, so at least we expect, like, some form of stability with this. Okay, so this is 591. So what happens if I just... This should be more... this should be, like, what? Smaller batches. This should be more fresh data, more games. Let's see what happens. Like, really unstable, huh? And it's a little bit worse, though probably not statistically so. So that's very weird to me because... Yeah, that's super weird, isn't it? You're getting more fresh games. Like, more stable. Oh yeah, look at that. Okay. So there is something to the batch size. Probably something to do with just the changing of the LSTM state now. Of course, you can't really learn anything with this stupid tiny network. I wonder if there is something to do with the LSTM. Well, yeah, actually, you do, because if you don't have, we don't have frame stacking, right? So we kind of just need the LSTM to be a thing. Okay, so actually that is better, right? We had to increase the horizon a whole bunch to make use of fewer ends. I wonder if now, hang on, if I can go to one environment and then leave the horizon at 256. Super long rollouts. Okay, you kinda can. So now my question is, does this let you increase update epochs? Or are we just still in this case where it all has to be super on policy? Okay, so we increase sample efficiency a fair bit with default hypers in just a few minutes of playing with this, right? A stable solve as well. Just confirm that this one doesn't work. But I suppose what is the question from this? Yeah, see, this is worse than before by a lot. It still actually does, like, pretty much, yeah, that's a solve, but I think you're messing with the LSTM state too often is the problem, more than anything. If I really wanted to crank sample efficiency, how would I do it here? This? Hmm. Feels gonna mess it up more, no? Probably better to do something like this. How many M's do I want? This would have to be an artifact. Well, no, it's not just an artifact of the LSTM. You also do need the bootstrapping term. Lucky our implementation is so fast. Oh, I suppose... Can we, like, just crank up the number of updates even more? Question, is it possible to place a flag on an env? Eval flag in building, two-player turn-based game. One against each other. Sweet. Nice to eval. Beta. Just mess with the clean PufferLib file directly. Like in the eval loop, there's there's a separate eval thing. Like it's, I think the function's called rollout or whatever. Do we still have a rollout function? Okay, no, it's this one right here, this eval function. It just has the loop directly. Just load your model in right here. Like a few line code change. Yeah, this is way worse, right? Well, I guess we'll see if it stabilizes. But it's definitely not like... This maybe is just way too many gradient steps, though. We can't do this many... Is it this? Yeah, 128 Ms. Yeah, so this is how you make everything super slow. Yeah, there's definitely some form of something like this, right? Of course, it's gonna nan out. Gotta, like, there's some form of this, I'm sure. The problem is it's fundamentally, at least for the on policy case, it's a hardware inefficient setup, right? Honestly, though, like, where's by advantage? You're just running, like, I'm trying to think where I take this from here, right? The problem with how fundamentally hardware inefficient a lot of these, like, sample efficient focused methods are. Like, you literally may as well not use a GPU for most of them. Of course, and we nan out still on this. The best one was this. Still working on advantage. I'm trying to figure out. I mean, I'm generally trying to figure out how we bridge computational efficiency and sample efficiency. I mean, the behavioral cloning thing so far. I actually did run a sweep on it overnight. So this has mostly solved the task in this is fewer samples with untuned hypers than my fast method with tuned hypers. in about twice the time, which is not terrible. Let me show you guys a cool result I got last night. So I just reran the sweep, right? On the method we were developing yesterday, which is this like advantage focused behavioral cloning thing. So we got up to, what is this, 300 and something? A bit over 300 score. It's actually more samples than before. Not great. I mean, it does learn, though. Thing is, we still have not found... We haven't found any version of this that really lets us, like, crank on the compute. We could go grab those hypers and see if we can get this to solve. That might be a productive thing to do. Okay, well, we understand with this experiment, right? We understand with this experiment that our current on-pol is pretty robust. And we can make it at least, probably like at least a factor of 2 more sample efficient already if we want to. And then we have our on-off pol thing here, which is in pretty much the same amount of time as before. With the untuned one, it gets 200 something score, and then there's a tuned version that trains for longer that can get over 300. What happens if I go to 2 environments and make no other changes? This is supposed to be more data scalable, isn't it? Yeah, but just doing this doesn't make it better. Fusion? Ow. How does that specifically help the sample efficiency / compute trade-off thing? Interestingly, this doesn't help. Oh wait, this is total mini batches. So then this shouldn't have done better. So wait, if I go to this is 2, and then I go to this is 4, does this do anything? The correct version of this, I think, loads the learning portion of the training like way more heavily, right? That you can make the sample collection portion will become less efficient fundamentally, but the hope is that you make up for it by being compute efficient on learning. This else like hmm. Free, right? That's way worse, really. That I would have expected to be way better. It's probably just super heavily overtuned, right? Any better than this, really? I mean, there's no reason to expect like the basic Q learning version of this to work either, right? Does it make sense to go play with the BTR implementation of this? I think it's just really hard to beat this on policy, like a good on policy baseline, right? I guess this would be... Would the other angle that I have here be to just try to make my on policy baseline um, more sample efficient? Like bigger architecture and stuff. The problem here is that I've seen the fundamental capability. Like, you need to be able to reuse some samples. Models in behavioral cloning. The model would be an independent improvement, wouldn't it? The thing that I'm stuck on is, how do you reuse samples without changing the whole algorithm to make it slow? Maybe we do just do the thing that I planned the whole time before. Which is, we do this whole thing twice. No, we're not using expert data. That's the point. It's very easy with expert data. We're trying to come up with a formulation of behavioral cloning that works online. And the thing is that this actually... The thing that's crazy is that this actually kind of does work. I guess the thing we don't know is... No, we do know, actually, that this works. This works better because we're reusing data. We know that. I could technically mix them. Hey, Convert. What if instead of doing them separately, what if I mix them? Does that make any sense? I think it does, right? I mean, think about that. Okay. I have an idea. This goes at the bottom. All right. Now, all right. So this should be similar. And now we should be able to play with one additional thing. I'm basically just gonna see what happens if I mix on and off pol data. We store it by value, we sample by advantage. Starts off as ones. Do you see what I'm trying to do here, though? I mean, I honestly wouldn't even be surprised if there's nothing magical about, like, the Q function formulation with off-pol. Both doing the same freaking advantage estimate. Yeah. Okay, so somehow this got to be wrong. Probably because I didn't do it down here, right? Okay. So this should be, again, roughly the same algorithm, right? Yes, this is roughly the same algorithm from before. And now, let's see about the losses that we've got. Actually grab our policy loss. Take this one here, yeah. This is the policy gradient formulation, right? This doesn't learn anything. Make sure I haven't broken something else. Yeah, I did break something else here, right? Because otherwise this would work. Changing robot from step controls to trajectory. What do you mean changing to trajectory? No, you don't want to... As in issue 1 control sequence for the whole trajectory, you definitely don't want to do that. That's like more classic control. What did I screw up here? Change the return? Oh. Did the clip loss? Do I go back yet again here? Oh. This. Hang on. Something's super screwy here, no? Just must have copied something wrong. Hang on. Hmm. What did I screw up from before? This should be the on-pal data, right? This needs to be abs for sure. Minus advantage. Oh wait, this is not... Yeah, this is not getting optimized. The ratio that needs... It's this. Okay, because this is just our on-policy RL now here, right? Yeah, this is just on-policy RL. This is our good baseline. We know it works, yada yada. What happens if we... I'm curious, what happens if we just sub this one little advantage calc? That's funny. It's actually massively worse to only learn from the positive examples, it seems. Alright. So we'll do this one. Now what happens if I uncomment this so we have off-pol data? Looks like we haven't totally broken everything, right? It still trains, and it trains better than before, like with our pure IL thing. Okay. And we have... Where are our clipping coefficients in here? We do want our clipping in here for sure, right? Vtrace. We have our clipping. We're computing. We're sampling by absolute advantage. Oh yeah, it's totally gonna change the it's gonna change the hypers here 100%, right? Like if we wanted something closer, we would do, let's do like a basic 1-to-1. Or actually, it's gotta be double, right? Oops, not 120. Thank you, Weston. May not, hopefully that doesn't open this on stream. Come on, move the window. Alright, fine. There's an exploit going around in Discord where I can't actually ban all the bots. Like, they literally don't have... Why don't I have... Oh wait, I do have ban on this. Here we go. Is it in general as well? Or did they just post it in dev? Looks like just dev, right? I got that one. Thank you, Weston. Dummies. Interesting that this is worse. This might just be the point at which we need to optimize, re-optimize hypers and such. I'm trying to think if this... What do we all think of this, though, as an algorithm? Like, you just do on policy, like, you just do your standard RL. You keep an extra, you keep the extra replay buffer. And then you trust PPO, clipping, important sampling, and retrace to keep stuff from going too far off. That seems reasonable enough to me. This would kind of be way better as well, wouldn't it? Like, if we get this working... Okay, it doesn't fix the rollout length thingy. But if we get this working, then actually we can fix quite a few other things using this. Yeah, no, we can actually fix quite a bit of stuff from this. I like this. I think this is good. And actually, we should be fine sampling absolute advantage like this as well. Okay, so let's see what other things I could have screwed up in here. Math-heavy paper. Conditional important sampling for off policy. Let me look that up. What the hell? No. Get out, Google. Welcome, SPY. Did they run experiments on anything? No, just giant math paper. I understand that, but this is a research stream. The vibe is more like what you'd find in an academic lab, man. So with a heck of a lot more engineering. Actually, this might be kind of useful. I'm gonna have to read this like fully at some point, but this actually might be kind of useful because basically that the off-pole correction mechanism is the important thing here. So we would just decouple batch size, right? To do this efficiently, we would just like decouple the batch size. I think we actually have the core idea in here now, don't we? If I do this. Good online course. Way to get up to speed. No, but I have a guide. I have a guide that links you to a bunch of good reading resources and things. It's more piecemeal. There's no single like good course. I'll link it to you. If you go through this, you will actually be qualified to. If you actually do this stuff, you will be qualified to like advance modern research and do a whole bunch of applications. This is the exact thing that like our top contributors have done. Okay, so here you see, right, if you don't store any off-pol data, we get the expected result. We can do, like, anything. We can even, like, use a tiny amount of off-pol data. Literally, even the tiniest amount of off-policy data messes stuff up, huh? Like, a little bit. When doing algo research, is the uptime your concern? There are a lot of things I'm looking at. So, there is the high data regime, where you're just trying to solve the task in the like lowest compute, lowest wall clock you possibly can. And now what I'm trying to do is I'm trying to expand Puffer to give it more axes on which we can crank up compute, increase uptime, but decrease sample usage. So it's many things. Crush all these freaking bots. The fact that you add just the tiniest bit of data here, I should be able to see it even more clearly if I do like this, right? Whoops. So 4096 samples. A tiny fraction of a batch. And we don't even get 700 as a result. Okay. Let's see if we can figure out why this is. We decide to keep data based on value, right? So you have your whole batch, and we've kept it based on value. I didn't discount the sum, but still. Some heuristic. And then it's sampled based on advantage. So if this data had low advantage, there shouldn't be any problem. This does not make sense, right? We have this tiny additional amount of off-policy data that we're keeping. The buffer at the end. So what we do here, so we always keep all the on-policy data, right? And then you're also, here, I'll show you. This is like a quick hacky implementation. But we keep all of the on-policy data, and then we concatenate it with additional data that we have in a buffer. So the buffer consists of however much off-pol data we want to store, plus the on-pol data. And then at the end, we compute the value. Where is it? Yeah, so here we compute the value of all the samples, and then we take the top k, and we leave these in the buffer. So the idea is that we're keeping around our highest value bits of data. But it's a very small amount of data either way, right? And like, up top, we're sampling by advantage. So if the data is not useful for training, it should just not get sampled. That actually make a difference, or did I just get lucky? Do one mini batch worth of data. Now there's like a fair bit of off-pol data. Okay. Starts off as ones. Good advantage. This one wrong. Is this like way worse, or is this noise? Why would you update the value as well? Yeah, you need to update, Oh, so this is gonna screw with the value function a whole bunch. I see. What if we do this? But you want to sample by a fresh advantage estimate, don't you? Oh, I see. I think it's because I didn't maintain two estimates. Does it matter what the original value of the data is? Like, does the value loss clipping matter? I mean, we can at least try something. Huh. Fine both ways. Welcome, Owain. What is the idea here with the clipping of the value function? Value minus n. Don't you explicitly not want to do that? I guess it depends what your motive is here, right? We also have the policy clipping. I mean, the clamped ratio is still differentiable, right? Am I wrong here? Pretty sure the clamped ratio is still differentiable. More frequent updates of... Yeah, this is the main thing, right? Is I haven't been able to get a good setting where we can crank sample reuse and really get much out of it. It's actually quite difficult to get that to work correctly. Okay, let's now increase the IL batch size to something more reasonable. So we're gonna actually do... That's like a reasonable amount of data to keep around. And it looks like it destabilizes learning a bunch. Like, fundamentally, why, right? We should be doing... I guess it's technically possible I have V-trace done wrong. Shouldn't be, though. Well, I mean, that's just like, you can just throw that out there. What does that mean here, right? We have several different forms of clipping that are supposed to prevent off-pol data from hurting us at the very least. To be fair, this could totally just be the sampling coefficients, right? Yeah, this could totally just be prioritize replay screwing with this. Hang on. This is the problem with fancy algorithms, right? There's a whole bunch of different knobs that mess with you. Okay, so let's do for now, because we're not gonna like resweep this. Let's do something that's more moderate. Like that's like enough data that we should. Let's see if we see an interference effect. Yes. Okay, so I mean it hurts learning, but it's still training like reasonably. Let's try a few different things here. So like first, just set this to 0. Recover our original form here. or update epochs. See what happens. You kind of get the same result, right? Now what happens? See if this solves. You know, it really does feel like we're throwing off our update somehow, right? It really does feel like we're just throwing off our updates. Because otherwise this should be stable, right? The idea is very powerful on its own. Does this not work? Combined with just curious here. Does the same thing as I saw before or not? Yeah, so this return combat level, right? The thing is with data reuse, you should be able to actually get something very quickly. Is it just like overfitting it super quick or something? Is it ever a good idea to have learning rate not decay to 0? Just increase next steps. I mean, there are a bunch of different learning rate schedulers, right? You could mess with it. At least from the testing that I did, it seemed like having a learning rate scheduler was much more important than the exact details of the scheduler. Okay, so 20 million steps, we're already up to 0.13 return combat. So it's actually already learning a little bit, right? Okay, so what I'm curious about now, if I set this to 0, how does it compare? Okay, well, I think this is better. Um, this is your proof here. We'll see if this catches up. I don't think so. Okay, so this is your proof of this, right? Um, we ran, I think it was 27 mil before. Give it 30. We'll give this one even a little longer to see. It is actually doing an okay job on its own here. Oh. Was actually stable and did help a little bit here. Having some previous data. You would expect it to as well. And this is one of the ones that worked with literally just full off-pol data. And this is with just a few samples of it actually as well. I wonder, so does it get better or worse if I do... Does this get better or worse? Yeah, that's definitely better. And it makes sense that it would be. Yeah, it's massively better. Okay. So it could be problem dependent here, right? Can definitely be problem dependent. Use the restroom real quick. I'll be right back. Holy. 40 million steps. It's already getting combat levels. Yeah, that's like ridiculously better. Okay. So, what do we do with that information? With breakout, we have like a 1-to-1. Here it messes up. It could totally just be the coefficients. I don't even have prio coefficients here. Hmm. Like really just not stable or happy. And this is a problem. We have it so that it appears to be doing substantially better on our hard task of neural MMO, but having a replay buffer, it's very, very fiddly with even like breakout. Really shouldn't be either. How stable is breakout generally? Like if I go to 1 here, to 0, does breakout work if you just crank up to epochs? It should just not pull from the data though if it's not good. Like it's already being sampled reasonably. The breakout with just 8 update epochs. One of the other wonky things about breakout is the episodes are so long. Like basically only getting to play one full game in the whole training, even though you're training this long. But, like it does train stably, but you like almost get no sample efficiency improvement, almost none, out of 8 update epochs. It is stable though. And then it hands out. Well, I say that and then it hands out right at the end. Cool. Just the brink of being stable, I guess. Okay, what about 8 update epochs on with all this IL data in here? Starts off good. Then it just decides, like, actually, never mind. Oh, why? I could compute, like, fraction on and off Paul, I guess. But yeah, it really does get messed up, though, by this, oddly enough. Why? I think it gets messed up even worse than if you just give it, if I just give it 1 epoch, right? At least this is fast and Literally gets messed up. Worse with more epochs. Hmm. This. Average samples from 10 epochs ago. Oh, also, experience replay has this weird decay. Right, it has like this weird decay where it goes to... It tries to go to uniform by the end of it, doesn't it? Yeah, we don't want that for this. It it could totally just be the sampling, right? Something tells me it's not just a simple have to resweep, but we can try that. Where's this clip? I think this is like decent, right? Give it a fixed, reasonable buffer size, yeah. I guess we basically see by the end of this. Does. I mean, it does seem weird to me that it's like that screwy. Um, on the other hand, it could literally just be the prioritized replay, right? Like breakout is kind of just a pretty on policy end because, well, is it? Not really, right? You're kind of doing always the same thing in response to the ball, just trying to hit the ball. But the episodes are really long. Hmm. Okay, well there's so many big problems with this stuff, man. I think what's the next productive thing I can do on this? could also work on the new env, test env. For whatever reason, it like just don't believe that it's going to be better if I just switch from this to a Q learning based thing, right? Like technically I am doing something at this point that is very much a be like an off-pol type thing. Am I totally wrong to think that? That like if I just go for Q learning based thing, it's not going to be better? We did get like the base DQN actually did kind of work. Well, it worked on the simplest possible problems. I guess I could do that next. And realistically, I'm not going to sit here and wait for a sweep to run today. I'm going to end up overnighting it. So I may as well take a quick look and see if this happened to do. Yeah, so like you do something, but so far you don't really do anything that's amazing. I guess the next thing to look at would be just forms of Q learning. What does SAC do that's different? I'm just going to look at the clean RL. This has SAC, right? The triad paper. I looked at this, yeah. Yeah, so this I understand. This is the key thing here, right? The problem is that the off-policy methods, the theoretical guarantees are there without the multi-step bootstrapping, but the algorithms just suck. And then when you start bootstrapping, you have to do all this off-policy correction crap that's not actually making use of the data. So essentially you end up with a algorithm that can theoretically reuse data but is just worse than your on-policy algorithm. That's the big problem as far as I've seen it. Right? That's the big problem I've seen. Does SAC have a smart way of dealing with this? I've never used SAC at all. Okay, so this actually does give you a nice sample-based thing, right? 4 freaking networks is obscene. Is this literally a one-step? One-step bootstrap? It's literally a one-step bootstrap. Maybe your problem would be wrong prioritization. Yeah, it can as well. I guess it's kind of crazy that SAC even works, right? I didn't realize SAC, they literally have a one-step bootstrap in this thing, right? Could I not make a version of this, like, really fast? If it's literally a one-step bootstrap, right? Why don't we just go grab this thing, right? I'm kind of curious as to, like... I'm kind of curious. Can you not mess with my torch version? Damn it, Costa. EQN plus prioritize replay. Single experience level. I don't think that does work phenomenally good. I think that's like a super shit like algorithm, isn't it? Literally, you have baselines for that stuff. Like if Rainbow and PPO are supposed to be competitive, prioritize replay is like one of the tricks that like is it's way worse without. There are other tricks that it's way worse without as well. This is the problem is you actually need like 2 or 3 major improvements before you even get close to like pretty basic on policy methods. Nothing close to P, but for off policy is good. Well, that's a useless algorithm, though, right? Like, if you're underperforming base PPO, that's a useless algorithm. And the problem is that there are a lot of useless algorithms in off policy, and you actually have to bolt a bunch of crap onto the base things before you get something useful. Like, here. This thing actually looks kind of good. Okay, so this takes Rainbow, which is already a kitchen sink of random techniques, and bolts on 6 more techniques. It removes 2, so it brings you to 10 additions. You have 10 additions to base DQN before it's a usably good algorithm. Wait, is this a single env? Is this literally intended for one environment? You've got to be kidding me. SAC, it's literally set up for one environment. That is the dumbest thing I've seen in a long time. That's like crazy. I wonder if their implementation even works for batched environments. It looks like they're supposed to. Why does it always insert a random ass character when I open a file? Drives me insane. Alright. Doesn't print reward or anything. It gets slower and slower and doesn't print reward or anything. Oh, I see. Hang on. Yeah, they assume a specific format of stuff. I honestly don't think this is going to do anything. Like, it's such a screwy regime of algorithms. Like, the majority of RL is just in such a screwy regime. It's like, I forget that I always say, Puffer is 1,000 times faster, Puffer is 1,000 times faster. It sounds like a marketing ploy. But, like, you literally just run defaults on stuff, and it's actually 1,000 times faster. So, I don't know. That was next. So yeah, exactly. That's the point. You can't. It killed the entire field, and everybody went over to work on language models because you can't get anything done at that speed. Now try to make it 1,000 times slower and have 10 times more code because no researchers can write code. Like CleanRL's the best thing out there by a mile. It's actually simple. It's just slow. Like honestly, the whole field owes a blood debt to Costa for actually making this exist in the first place. Probably without CleanRL, I would have given up and just said this field is stupid by now. At least CleanRL gave me a starting point for like, okay, I can do this but fast. Don't use a lib torch like the C++, because literally nobody will use PufferLib if I do that. Why am I not getting any infos? Ah. Eh, funny. Yeah, the thing is, it's C++, but I don't even think it's, like, good C++, right? Do, like... And... Buffer size? Where's batch size? It's not like this magically works, right? It's just super slow. to steer towards and reach your goal. Very easy with large step size. At lower step size, better rewards. Yeah, there is a thing. So you're increasing the credit assignment horizon. So the smaller the steps are, the harder the credit assignment is. Um, if you need it to be small step size to be accurate, you do some sort of curriculum learning thing. Just start it near the goal and then, move it farther away over time, or like randomize distance from goal, something like that. It'll solve. Okay, so this is just getting slower and slower and is not even solving anything. It's really not even worth messing with anything in the hardware inefficient regime, right? Like, you're just back to square one with, like, RL being a super cursed field where nothing makes sense. I mean, this is literally running on, like, what? 1% GPU utilization? The thing that killed the field in the first place. This is kind of cool. At least this is up to, like, 500 or whatever under this circumstance. Substep for physics and policy up to 2 substeps, yeah. Okay, I don't know what the point of this exercise was other than to remind me how ridiculous everything is. 1,500, 200, yeah, exactly. But you see what I'm trying to do, right, Tim? Like, we do need to bridge the compute and sample efficiency gap somehow. And, like, realistically, the only way to do that is with massive sample reuse. Because here's the problem, right? If I run a ton of parallel environments, I don't really get to update my policy very much before, like, to get fresh data. Like, you can't really do sample F with a ton of parallel ends. So the forward pass is just going to be slow. I guess I can try. Maybe we just go over to some of the off-pol stuff in Puffer. Robots and imitation. Imitation on its own is easy. It's like the mixed data collection setting that's hard. What the heck? So here's your basic Q learning thing. Even with Puffer, I got 10 SPS. Yeah, you definitely 10 FPS is something's wrong. Should never be 10 FPS. Does anybody know Soft Actor Critic doesn't do a distributional thing, right? Does anybody know how the hell Soft Actor Critic works without distributional RL in there? Okay, so this is the basic cart pull thing. This give you QA already? Got my RL exam on Monday. I forget that there are actually RL courses out there. Do tend to forget that. Is it any good? Why is it like this? Ah, does get flattened. You end up... So it's like kind of, Kevin. You can actually get something to kind of work. Literally just doing behavioral cloning on like best data. I also this morning here, what I did is I took that and I integrated it. Well, I took that and I basically added a buffer to the existing Puffer online RL, which seems to be doing better. And I'm relying on a couple different off-pol correction mechanisms to keep it stable. And it's done it's done okay. The thing that's weird is I actually have it making neural MMO learn way faster, which is like the hardest environment. But just having the data around it all seems to make it harder for stuff like Breakout. I can't figure out why. Like it should just not sample the off-pol data. I mean, I gotta give this an honest try. It's so far-fetched in my mind that, like, you would be able to get anything out of a one-step bootstrap. I didn't actually realize that the soft actor critic doesn't... It's literally doing a one-step bootstrap, but it's so hard to compare because it's, like, the most inefficient thing ever conceived. N-step TD. Yeah, that's like probably Sutton and Bardo, right? The problem is the N-step bootstrap actually doesn't really work. Behavioral cloning, filtering, or filter with advantages. Yeah, so the thing I did yesterday was just store all the data in a buffer, um, and like keep the highest value data, not advantage. I believe I did it by return like trajectory reward sum plus final value, and then you sample it by advantage, and you just do weighted behavioral cloning, which looks very similar to onpol RL. And then today, what I did is I just literally did the on policy RL, but I just do it with an additional data buffer that you can sample from. And then I'm hoping that between clipping and, well, the fact that between clipping and the vtrace component that's already embedded in Puffer Advantage, that it keeps the data generally useful, which it should, to be honest, because like the advantage computation should just go to 0 or whatever if it gets too off policy, because it stops trusting those samples, I would think. I'd have to double check. I'm pretty sure that's what should happen, though. Was that advantage weighted regression? It was similar. It was similar, let's say. I think I'm just gonna have to go to the other environment build stuff soon. Drive me nuts. Direction with on policy with clipping, does that mean you also stored old pi for waiting for all the data in the buffer? You just have to store the log prob of the action you selected, right? That's all you need. I mean, I guess you could technically do full KL div, but I'm pretty sure it's just you take the log prob of the action that the old policy selected, and you construct a ratio with the new probability, right? You could model the full distribution, but I don't think that's the normal formulation. Why is this so confusing? Oh, I just have this set up in like a totally weird way, I think, for yeah, I just have this set up in like a totally weird way for this. It almost makes more sense to go off of the cleanrl SAC initially. So freaking slow though. You can just tack it for now a little bit. Keep pushing on it just a little bit. Doing it this way. Doing stupid things here. Why is the mini batch like this as well? Oh, because I have 8192. I forgot about that. I'm not really trying SAC. I'm just trying to get something with a one-step bootstrap to do anything. I don't know. I'm messing around with a bunch of different things at the moment, Kevin. Like, honestly, the whole literature is just screwed. Like, it's completely screwed. Be 16K. Should be 16. Okay, so this is now batched. This is like batch Q learning. Okay, not amazingly stable, but it's a thing. It's there. So how is this supposed to do? What does SAC do on top of this that's so special? That like everyone always shows it matching roughly PPO. The right one? Did this for thing instead. Next log. Get action on obs. Of X. Okay. So this actually. Oh, okay. So there's a separate actor in a soft Q network. Okay. Trying to derive the entirety of RL. it's not that I'm trying to rederive the entirety of RL literature from scratch. It's that I'm trying to figure out how to make the things actually work. Because I mean, if you try any of them, none of them actually work. I'm trying to fill in a bunch of holes, basically. I mean, we could make a version of this fast, right? Yeah, we could make a version of this fast, right? You got like, well, you can get rid of some of them. This is like the double DQN thing right here. So there are other off-pol variants where you get rid of two of these. Um, I'm more confident that if we make it work, I can come up with workarounds to strip things out and make it fast. The question is whether this actually does much on its own. Literally, best thing is gonna do it would be though for me to like start from 3.0 fresh again, annoyingly enough. The thing that I didn't realize, okay, so the key piece of missing information that I didn't realize here was that Soft Actor Critic doesn't have a multi-step bootstrap and somehow does okay. Right? That was the key thing that I didn't understand. Which should make a difference. Okay. Let me use the restroom real quick, and then we'll try. We'll see whether this does anything. I should be able to get this to match PPO, but fast, we'll see. I'll be right back. I have some ideas of how I'm going to do this. So screwy, though. Okay, so we have all these little networks. Not normalize my observations. Do I not have that in the checklist? I'm pretty sure I have that in the checklist. Normalize your observations. Yup, I'll do that. Never did. Well, only so much I can do for that, eh? Are you using reparameterized? Are you using reparameterization trick to backpropagate through the actor update? No, what I was doing here is I have the 4 fully separate Q functions, and then the actor just has its own LSTM, and the Q functions don't. What reparameterization trick? Through the actor update. I haven't even gotten there yet at all. I'm literally just setting up optimizers. Get action. I think we still get logits here. Right? Yeah, you just need to store actions. No values to store. And I think we're already at the training loop. Yeah, so we are at the training loop. And we're gonna just ignore all this advantage stuff. Action. Cleaner. Budgets. We do actions like this. And we need Q. Next. This, right? And then this doesn't take. This is fine. Use action probabilities. min q function next target. And then next state action prob. You want full action probs, I guess, yeah? Is that just log softmax? Is that just softmax, actually? Probs. So is this not just, this is just softmax of logits, right? Wait, next state. Next state. Oh, this is on next observations, I suppose. Okay. We can do it either way. We're just gonna have to index. Because it's gonna be action probs times torch.min. Okay, we'll see if I've done this correctly. Probably this is the crucial don't screw this up. And then Treat. Okay, so we have to now be careful with this, right? Because this is the reward. X. Rewards. No, MB rewards. And this is the one that I have to be careful with, right? Because it needs to be the next target, so it's this, I believe. And then this will have to be like... What the heck is this? With Torch Nograd. So this whole thing is under a Nograd. Okay. One. That's so inefficient, the way that's implemented. Okay, we'll have to change that. We can at least share some of this. Oh, actually, no, we can't. Lovely. I think it is something. It's something like that. UF plus. And this one's got to be like this, right? Why are we calling get action again? Oh, because now we step... Okay, and now we do it again, for some reason. I mean, this is still... This is actually going to end up being less complicated than the current implementation of the algorithm because of the lack of prioritized replay. Of course, as soon as you go stick that back in, it gets worse again. We need action probs as well. And now this thing here, here's your actor loss. Okay. Is there anything else? No, just the target nets. Wait, alpha loss? Are there 3 optimizers here? Oh, it's just, that's just for retuning. Fine. We can ignore this for now. Alright, so now we get rid of all this stuff. Like, kind of okay. No gradient clipping, nothing. Tons of stuff we can do here. It's gonna look something like this. We could very easily clean this up. Eyes up. And we're actually getting, like, reasonably far into the algorithm now. Yeah, so that gives you a min, right? Action probs are screwy. Why is action probs like this, yeah? Oh, because logits. Wait, what? This looks good to me, doesn't it now? Did I not do this correctly? Hmm. Just do 2 of 1 target. Not next. Want to get something to be useful today. Uh-huh. Oh, you know why I see it? That's just dumb. Oops. And then we can sum this, right? Yeah. And of course, this chunk here, this. Crazy they use 4 separate Q functions in this thing. And Hobbs. This is probably the exact same thing as before, yeah? We'll actually be able to reuse a couple of these computations, though. So it'll get faster. But even like this, we should still be able to get like 1,000,000 steps a second or whatever. Okay, well that is the initial implementation. The initial implementation right there. Doesn't seem to do anything. But we have it running, and it's actually running pretty fast. Now we just go bug hunting, right? Oh, well, I didn't sync the damn networks. That'll do it. Target network frequency. Yeah, this whole, like, Q function synchronization garbage. 8,000. Target network frequency. Talk, maybe? I actually think I just want to do... And tau? They have this thing set not to 1. Oh, it's set to 1. Okay. Heh. Quite collapsed. Go look at the cleanRL one. See what I've missed. See many things. Why do they do a categorical followed by a sample here? Oh, because this is, yeah, we have this as well. This is fine. But this takes policy parameters with 2 parameters. And this takes, what the heck, where the target optimizer go? Wait, what? Huh? Oh, no, you don't. You just get, right, the target gets copied. It doesn't get optimized. Cool. And then the actor optimizer needs the encoder, the decoder, and the LSTM, right? Okay. Have all this stuff. And we get to training. Function. Okay, so we have to make sure we did next observations correct, right? So I do on MBObs, we do a sample, do view logits, probs. Okay. Get action. So then this can go, wait. This actually can go in, this whole thing can go into this no grad loop, right? This whole thing goes into the no grad. Now, logits, action. Do min, alpha, and then this is next state log pi. Yeah, so this is the full distribution. Now we do Q function 1, the target Q function, on next obs. Okay. So I've done this on current obs, but I have them in a buffer that's going to get shifted by 1 anyways. We do this min, alpha, next state log pi. Okay, so I think next state action probs, and then state log pi, log action probs. I think that's fine. And then you sum along this dim, and then you offset it, right? So it's +1 minus terminals times gamma +1 minus MB times. Yeah, this looks good to me. And then you do this Q function. I don't know if this gather is correct. We'll double check this. Okay, but you do this, and then you have a Q function loss, which is mean squared error between next Q value, which is already offset by 1. Okay, so I think this looks good to me. And then this we don't care about. Yeah, this looks good to me. Let's go make sure we're doing this. This sampling operation I know I've gotten wrong before. So let me see if this looks good. So we do 1, 0, 1. Wait, what? Hang on. 1, 0, 1, 1. So 1, 0, 1, 1. Yeah, this actually looks correct to me. Yeah, no, this is correct. So, the gather is actually correct here. What do I have wrong then? Well, let's log some losses. Did I delete all of them already? Hang on. Where's the Q function loss? Well, it doesn't blow up or anything. There's another loss though, right? The actor loss. Those are both reasonable numbers. Let's check if the update frequency is something totally obscene. How often do they update the target network? Wrong one. They update the target network. Frequency of updates for the target network. So every 8,000 samples, which is, in their case, that is quite uncommon because like 100 something updates, right? And then what is this target entropy scale? Oh, auto-tune entropy target. Well, we're missing something, yeah? Oh, yeah. Just making sure it's not a terminal issue. Way easier to catch on breakout. But yeah, no, this doesn't learn anything. Welcome, Treeform. I'm currently messing around trying to get SAC into PufferLib so I can run some comparisons. This is definitely not learning. Well, the rewards kind of goes up, but it's like, it's below the noise threshold, really. Yeah, soft actor critic. The thing that I hadn't realized about soft actor critic, I figured that it had like an end step bootstrap, like all of the other off policy methods. But it doesn't. It actually does. Well, I guess it depends what papers you believe, but comparably to PPO with only a one-step bootstrap. Of course, I need to actually get it to do something for that to be evident. We do get action. Hang on. Lost max logits, action prompt. Yeah, this is right because we do Lodge. Maybe there is a mismatch here, right? Maybe you just want to return probs, log probs, right? Maybe you want to do like this. Okay. So when you collect, or you step the end, yeah, you just want to collect the actions, right? So we don't really care too much. Yeah, we actually do not care very much about any of this. So we just get actions. Man, so we can just get over here, right? We don't need MB log probs. We don't need this. We don't need this, right? Some ways, if this works, it will actually simplify things a little bit. We have action probs. So this should just be probs log prob. Like this, yeah? Prob, log prob, yada yada. Prob. Okay. Budget. Prob. Prob. Find a bug. This needs to be. Oh, and log prob also needs to be. Budgets. Okay. Now this does need to get reshaped, right? Bulls. You. Rob. Seriously? No. Hang on. Okay, so this is now running. Still doesn't train. Really? You do all that, it still doesn't train? Okay, we go hunting for more bugs. Just fighting you? Yep. Compile false the whole time. Darn. Programming would not be fun if it worked the first time all the time. I disagree. It would be dramatically more fun. Because I would just solve one thing, move on, solve the next thing, and then all the problems would be solved. trying to think if there's like anywhere obvious I would have messed up. Hang on. This is on obs. Obs actions, right? Next Q value. You sum these, yeah? What the point of that is, but sure. And here you have your targets. And the next one is going to be acquired by... Yeah, I think this is fine. Rewards of 1. Eh. Action. Oh, this seems fine. That seems completely fine. And that's all there is. Like, there's really not that much to this algorithm. Add backwards. Up. The actor loss is going to be probs. Alpha. I mean, this can be log prob. Doesn't make a difference, though. Me mean on this. Min Q function values. This one doesn't need to be offset, right? This one's good. We use action probs for temperature loss. No, this is not needed. It's just a fixed alpha. And where's alpha? Alpha times next stop. Next. Fine. Whole thing looks reasonable to me. Oh, okay. It's the fact it's jumping around. It's probably doing something. Might need to just fix a bunch of other things. Just to be sure that it's not just this. Jumping around the scores. Oh, it's not it. I still have bugs in here then, yeah? It should pretty much any reasonable algorithm should jump above 7. almost instantly. It is weird that this is slowly, ever so slightly going up, I'll say, but it's not like a significant result, like even directionally. You can probably just maximize entropy and do better than this. Yeah, but like it should, any reasonable algorithm should have should have gotten it way before then. Like you can literally run vanilla DQN and get that immediately. Or more likely I have something bugged. There we go. Let's see if it's consistent or just jumpy. Okay, so let's get this to be stable and see if we can run it on breakout. I don't know how frequently we should sync. Like, do you want it to be synced very frequently, or does that screw it up? That screws it up, right? Tau equals 0.005. Does that make a big difference? This update rate seems to matter a lot. Oh, well, learning rate. Way worse? Huh, way worse. Believe so? Okay, we'll try that. It's weird because the CleanRL defaults don't even have, they just have it set to 1. I mean, it's possible I still have major problems in the implementation as well here, right? Yeah, carpool is like so incredibly easy. You can have stuff be completely wrong and just still kind of do stuff on that. Are you just supposed to run way more updates? I don't think so, right? Not like magically, oh yeah, samples. Four neurons. Yeah, you can solve it with four neurons, sure. I think it's maybe Pong is four, a lot of the Atari is six. But that's not really the point of this. Can see, figure out what it is. You have your actor optimizer. Okay. Did I miss anything crucial here? think so. Same learning rates. Count factor. Steps from Snyder. This kind of works cartpole, right? And just mess with the hypers a little bit. Really. I mean, it should just, like... Literally, Q-learning works on this. It should totally work. Is it, like, too much entropy? No, that actually breaks it instantly as well. Thing 9. Next state. Make sure I did that in the right order. Probs, log probs, right? Prob, log prob. Target. And alpha. That's definitely fine. This stuff is, like, pretty basic, though, no? So Q value. Your loss. Supposed to match up. So this is take your obs, min, alpha times log prob minus In actor. Yeah. As far as I can see, I have this set up correctly, and it's like really underperforming. Like, really, really underperforming. Eight epochs. What else would I have to mess with? Yeah, it doesn't work on Pong at all. Somehow works on just cart pull. Guess the easiest problem. And not even super consistently. Yeah, see, like, that's a mess. What? Oh, this should definitely, like, work way better. Oh, wait, hang on. We do use MB actions here, yeah? That was the one thing I wasn't sure as if I had grabbed the actions correctly. Seems like we do, though. Wait, why is this a sum? That makes sense. Next Q value. Well, this is a gather. Weird that this is a sum. How does this make sense as a sum? Hmm. Ah. Nothing else in here. This is literally just a sample. Target loads the state dict of the, target loads the state dict. Fine. Am I like not optimizing the main network somehow? Encoder, decoder. Where I should be. The self policy. You got your encoder, you got your decoder. Oh, that's bad. Yeah, okay, that'll do it. Hang on. Yeah, hang on, hang on. Oh, wait, shouldn't they be linked? They should be linked, or no? This might be doubling up. Like, they should be the same, right? Hang on, yeah, I thought I'd seen something, but that's not it. I mean, then it literally wouldn't be able to learn. Yeah, it's the LSTM weight that you want. Anyways. That's it. Layer norm. I don't have a learning rate schedule on this actually, right? That's kind of a big deal. Okay. And it's still not amazing. How do you make soft actor critic actually learn something? Does this, but like, come on. Ooh. This one doesn't take... I don't know if that changes anything. I actually don't think that does change anything. Heck. We just... we have to search over random seeds now? Is this where we're at? Is there no, where's the... this gather here? Okay, so this Q function doesn't use... How can you tell the score? Yeah, it's the score. So cart pull, you just get a point for every step until you fall over. And if you get 200 points, then you're balancing it perfectly. Something is just wrong. I don't know what. Train both of these against the same target here. Do this gather, which I double checked this gather, and this but gather is fine. Do policy, Q function 1, Q function 2. Boards plus 1 minus done times gamma in Q function on the next step. So this do next. in Q function, next target, probs, min of the two targets minus alpha, prob. Have log prob log prob here from ours. Logits and state. Empty, and this one, which is fine. Yeah, these things are not helping. It's so incredibly difficult to get right. Is it a bug? Is it the hyper suck? Does the algorithm suck? all over the place. I mean, it's like, at least there's something correct here. Otherwise, you wouldn't get, you wouldn't see any learning, right? Adjustment of weight. No. If you randomly are adjusting weights, you won't get a score like this. It's like directionally correct at the very least. And but I don't know like what is. I have no idea what the problem is, right? If it's just hypers, if I have a bug. On the original code. The problem is these algorithms are fancy enough that you're not gonna ever really be able to do that. Like if you're never gonna be able to really get like one-to-one comparison like this. What's the baseline score with PPO? Instantly solved. Like by the time it's printing out logs, it's already solved. And this thing should just have instantly solved everything. Especially, like, I'm giving it so much more fresh data as well. And this is random perf here. $13. Yeah, exactly. I mean, on a faster machine, it'll, like, be basically instant. Okay, I mean, this does do something now, right? Like, it's not random, but it's just bad, and I don't know why. Algorithm. What the hell could I have possibly done wrong here? Are the QNet... I mean, no, it shouldn't matter that the QNets I have kind of suck, right? And nothing. Nothing at all. Why the heck did Restream just sign me out? App. Okay, there we go. Why the heck is my restream being dumb? Okay. Well, whatever, I got it now. Okay. You don't use any of this stuff now. Go get gradient clipping. When you were at Stanford, or I don't know, MIT for your undergrad, Stanford was undergrad, MIT was PhD. Do you have like people who were admitted to school with bad grades, accepted due to impressive extracurriculars? I don't know about impressive extracurriculars. I definitely know a bunch of people who I have no idea how they got in. It's tough to get in with bad grades because it's like having bad grades. It's such like a basic checkbox. It's like failing to get up and tie your shoes in the morning, on the way out. How they entered. I mean, there's like a huge gap. Like you meet people who are absolutely brilliant, right? And then you meet people who are like, all right, this guy's a moron. I have absolutely no idea why he's here, but okay, I guess. Well, yeah, let's just go get grad norm. Let me just one thing real quick. Zero grad. I don't think it makes a difference. Unless it's possible I have my loop set up differently. Because that wouldn't make any sense, though, right? Yeah, because it has to be optimized, obviously, right? Otherwise, you wouldn't see. If I had that as a mistake, then you would literally wouldn't see anything work. I will say the one thing I think is kind of ridiculous is that people get rejected from PhD programs over not having great grades. It's like I almost like question if you do have perfect grades coming out of undergrad, I almost question what the hell you've been doing with your time. Okay. Is this replicable? Not precisely. A heck of a lot more stable though, right? Update frequency matters a lot here, huh? Every 64 steps, maybe? Okay, so that is... I mean, that's closer. Interesting, it breaks with 4 update epochs? Really? This noise? Didn't break. Now the whole point of these things. I mean, okay, it's not terrible. Yeah, literally no signal in here. None at all. What the heck? That's like bizarre. You also shouldn't need that number of update epochs for freaking cart pull. I mean, cart pull should be solved in like a tiny number of steps. This shouldn't be remotely a challenge. I only have it kind of training. Where it's like one of the only damn fields where you can have worked in the space for 10 years. You can have like very deep knowledge on a ton of different things in this space. And like literally basic algorithm implementation from scratch. Good luck. Not gonna work. Is there like Do I have like an extra log or something? I've checked this so many times. But I don't know what else it would be. This PufferLib, where's the clean arm? This shouldn't be important, right? It literally is random when you start it anyways. Get this. This actually does tell me sample reuse, right? Update frequency, is it 4? Yeah, so they have 8x sample reuse. I guess it is totally possible, but it's just like a crappy algorithm that you have to crank the compute on, right? But 8x, that's only like 2x more than on-pal for these same tasks. So your loss, probs. It's really not that much code. There's really not that much space for stuff to be wrong. Um, Particularly for it to be doing worse, with more samples. Oh, I mean, still, like, come on. It's more stable than it was, but it doesn't frickin' solve cart pole. Like, what else is in SAC? Doesn't even have like prioritized replay or anything by default, right? It just has like a circular buffer thing. Is there anything else I haven't messed with? I feel like I've messed with everything. Why does it take so long for it to start learning like anything? Weird how it does that. I mean, the QNet, like the architecture is pretty dumb, but like frickin' cart pole, right? Yeah, it's frickin' cart pole. It shouldn't matter. I understand this. policy. Fun. I had to check one small thing. I'm kind of at a loss here. Like, I expected this to do something. Do I just have, like, crazy hyperparams or something? But there really aren't even that many hyperparams with this, right? Like, we cut out most of them. Literally, we've cut out almost all the hypers. This massively? Like, no, right? There's no way. Right? It shouldn't be this brittle at this scale. Like, basically, you literally can solve this problem for reference just by behavioral cloning the best lucky segments that you get. I'm giving it on policy data, pretty much, which should be better than normal. There should be like a best case scenario for it, pretty much. It should be super easy to have this solve. Like, look, if I got this to solve long and, like, decent enough on breakout and then I have to tune it, that's one thing. This is just not doing remotely close to how well I would expect it to. I mean, do we have to think about epochs here? 64. I mean, we know that this is sensitive, right? Oops. We know that this is sensitive. Maybe it's every 16 epochs we do this thing. Okay. There you go. So it's really, really sensitive to the update interval here. It's still not stable, by the way. Why doesn't this give you a stable solve? Let me go double check, make sure that the reward thing is what I think it is. I want to just be sure that I haven't screwed this up. Okay, I think that this is confirmation, right? This can't learn. And it's confirmation I had it right this way. This is the one I would expect anyways. Ward plus the next Q target. Alright, let's see. Can we get away with updating this every 8? Is that the play? Let's see, this completely crashes it. Doesn't learn a single thing. So sensitive. Okay, at least this is like reasonable, right? I wonder if the alpha is like... 4 M's. Horizon of 8. Can we get this to do anything on Pong? Best paper at RLC, besides my own work and my friend's work, I assume? Honestly, there really wasn't anything stand out that I was like super excited to go look at. I mean, it started optimizing for a little second, but it's still like so freaking bad, right? Do I not have like some major bug in here? And talk RL. Got the shilling down. Oh, that was like just a super clumsy impromptu interview. If you want to watch my actually properly prepared talk, it's on the Neural MMO YouTube. Like that I'm actually proud of. That was a good talk. Algorithm just feels super weak to me. Are there any other major details I'm missing? I don't... Hang on, I don't think... I really don't think so. I mean, I guess the, we're using really crappy nets, but it shouldn't matter that much. Maybe for Pong and stuff it does. Hang on. Let me at least get us, like, one... Let's just at least get it, like, one extra hidden layer. Alright, Mr. Off-Paul, did we work? Well, it didn't break it. For, cart pull, at least initially. Weirdly stuck. It's ridiculously slow. I mean, what's the deal with this? Is this just a stupid algorithm that you just, like, have to crank a ton of compute into before it solves even simple problems, but scales better? Like, kind of ridiculous. It's annoying because, like, this is, like, I've pushed it to a point here where I can't be positive it's correct. So I can't say, oh yeah, the algorithm just sucks, because I don't know if I have a bug. I don't think so at this point. Solves the simple env. I've, like, roughly calibrated it as well. The update frequency. Okay, I've roughly calibrated it. It only solves freaking cart pull, and it doesn't even fully solve that. Doing well. No, this one wasn't doing well with neural MMO. It was a different algorithm. We have this. So this got up to like 550, whatever. Doesn't solve breakout, though. You know, I really thought that I was gonna be able to get something quickly that at least did, like, okay. And I thought, you know, maybe I won't be able to tune it as good as my algorithm is. Like, the puffer baseline is just incredibly It's like an incredibly tough one to beat. Because everything out there is just like so incredibly, ludicrously, laughably slow by comparison, right? Right. Does anybody see a bug? I don't see a bug. Like, it looks to me like I have this pretty reasonable Q value. Basically identical code. I'm actually here. Let me commit this. Guess I named it wrong a little bit. Fine. Says score. Um Doesn't look like it's working to me. I figured we'd check the reference implementation, right? Maybe it's just, like, stupidly slow. Maybe that's the deal. I think I might have undersold PufferLib a little bit when I say 1,000 times faster. Because now this is like 5,000x faster, right? This is literally running under 600 steps per second. With like tiny networks on the fastest possible environment on a 5090. It's also not even solving it. This is the reference implementation as well. So, this thing just not work? Have I been here, like, trying to match an algorithm that just doesn't frickin' work? This is actually now at, close to the steps that I did mine for. And my version's actually better than this. I mean, I feel somewhat better about this. But, like, what the heck, right? Oh, hang on. Supposed to be a batch size of 32. Maybe it needs the tiny batch. I thought it's gonna be even slower. Try it with the 32 batch size. It's gonna be kind of funny to me if this only works with tiny little batches of data. Be super cursed. I don't know if it's doing any better. Supposed to be 5 million steps. This norm is not good for And I caught a bad norm. Maybe it does work. Ah, QNet also has the 255 norm. This is such an easy problem, like, it should insta-solve. This make end. Honestly, hard to say if it's learning. I'm trying to make sure I don't have like some screw up from Puffer. I don't think I do though. Oh, you know what? Hang on. I just want to be sure. I think this might have been it. See? It's actually hard to say. The trajectories are super mixed. Yeah, this is learning. It's weird. It's like, it is actually noisy, though. The segments are really noisy. But it is learning. It's funny, though, it does actually take it, like, several minutes to solve frickin' cart pull. Like, so, I mean, if this is supposed to be the sample efficient algorithm, and this is what it does, so noisy that it's like, it's still getting bad segments at this point. Nothing else I'm missing, right? Think so. I mean, okay, we see that this just continues to bounce around a ton, but it does do something. Let's just make sure there's not do Pong real quick. Because if this solves faster, then it's like, alright, there's something screwy. And if this doesn't work, then what? Just a crappy algorithm? I mean, that's probably fair, right? If I tried to implement myself and I used, like, one of the best reference implementations. And then what would that imply? Basically, that a lot of these control tasks they're used on are just, like, really stupid, really data-constrained problems. Not a single episode. The reward. Well, that's kind of surprising. This is a random paper, right? Yeah, this is bad. This is it fails Pong. 0.7 break. So this is just bad. They get results. Across Atari 100K. Okay. They have results here. And why is it efficient 0 is the best one on here? The fact that they actually got this to do anything, though. I don't understand why there's this much of a discrepancy. Like, I'm literally seeing this do nothing across both my own implementation and the CleanRL one. Oh, you know, I wonder who implemented. I wonder if they did it off of this one, and they got a bad port of it. Hmm. I'm down to do other stuff. Like, I'm down to try this. The MCTS is probably a bit of a pain. No code. Lovely. Yeah, this is stuck at -21. Okay. Did you figure it out, Tree 4? No. I think it just sucks. Yeah, the problem is this sucks. Alright, we'll do that from this, I guess. Okay, so we do self.h. And then the dynamics function. Predicts state and reward given state and action. What in the hell did this thing try to autocomplete? Oh wait, this is actually easier. Because this actually takes num actions at hidden size, right? And it's size plus num action size. Then we'll just do a self dot state code. Like this, exactly. Okay, and then there's a policy function, a value function. I think this is all you add. Let me make sure I actually understand what they're doing here. Replaces MCTS with sampling-based gumball search. Okay. Train jointly. No code for this, is there? Ah, it is. Okay. Please be good. Okay. Worse. Oh no, it couldn't. Ray and frickin' Hydra. Their code? Yeah, this is their code. I think this is pretty much all of it. Except the network, maybe? Um, or tree.search. Imagine episode. Do they use the MCTS though in the eval loop or no? Or do they only use MCTS in training? Dynamic function, supervised learning method of using the true reward. Very complicated method. Okay, but you do actually... You implemented this thing. Over here. Monitor. I'm going to see what I can do about this. Is dynamics, right? Is dynamics. So H takes in takes state action. State action and outputs next to state action. Yes, it does. Okay, so you have to give it the action from the previous time step, I suppose. Oh, it outputs reward, not action. Duh. So you do reward decoder. Let's just see if I can get a dynamics model to be trained jointly with the environment for now, with the policy for now. So for this, you need to do Well, actually, you just train the policy as normal, right? You use the policy as normal. And then you just add in an extra dynamics, right? So you have state and action. Policy. G. Was it G? And do you need the encoder. Yeah, you need the encoder. So state equal comps head actions is gonna be this. Okay, you can do like this. And then we do dynamics. Okay. And then we just add these in. Obviously, there's no planning or anything. Dynamics takes you do not need num ops. I see you have to embed the action. Do action embed. State. See? Okay, so you just have this auxiliary thing, right? And these losses should not be 0. This one has to be rewards. Why? That's why it doesn't matter. Huh. Okay. Yeah, there's your reward loss. And this does not get in the way at all, obviously. Now, how do we do this via search? So they take H. This. and then they sample action. Wait, I thought that they do this? Do they do this during training or just during the collection of actions? Is this just done during the sampling-based Gumbel search? No, wait, is this actually just it does supervised learning method. Wait, is this totally different from Dreamer? Forms planning, yes. But then it does this to pick better actions, right? That's just the problem. I can just figure out how this planning thing works. So you take H gives you state. You sample actions, it says, from state. Presumably with what? The policy function, right? Okay, so we change it so that policy takes state, right? Is H. So instead of encoder, well, H is the encoder, right? Not having code observation. Okay. Now we're sharing an embedding layer. Wrong. It's not designed to be hmm. Okay. Let's do encode observations. Has forward. I returned everything correctly. That's weird. Well, we haven't made a huge ton of research progress today, but you can't say it was for lack of trying. I've been pretty well focused up today. Just how research frickin' is. I guess I've been somewhat biased against how world modeling works since we spent a whole bunch of time trying to replicate the Dreamer paper and it was kind of crap. See about this instead. Search has always made more sense to me than Dreamer style stuff anyways. Oh, okay, I see. I see it. It's code. I guess I would feel kind of stupid anyways if there were just a bunch of free wins lying around. But being this crap. You need state for. Actually, yeah, what you want to do is this embed budget. Okay, so you have these separate. Okay. Still good. Still trains. We have a world model as part of this now. With an LSTM. Okay, so the thing that we don't know yet is how we're going to do all the search crap. So I can't tell, are they basically using the model to, like, the planning model to get better actions fast? Or are they training on it as well? They do have JE and everything. Is this how it works, though? They say that they have, there's a queue function, though, as well, isn't there? So they have this tree search thing. I saw the function in here. This is the hard part. Most likely. I thought they said they don't use MCTS. Use gumble noise. Yeah, they don't use this thing. Heh. Jeez. Policy. Yeah, I don't understand how this only has the policy. Or how their search works. Gives you values, policies, and best action. They're like calling something weird a policy. I think, are they just calling it the probability vector over actions? I think they are. Give you the value, the policy, and the supposed to be search. Okay, search. This takes in the model, batch size, dates, root values, root policy logic. And they have LSTM as well. It's a pretty messy looking implementation. And I should be able to figure out how this thing works now. It doesn't seem like they have, they must have a model. Friggin' lines. Agent. Not the agent, dude. You have a train function that's not the agent. Oh yeah, they have it. This code, I guarantee you, is super slow. But faster. Main thing I need to understand, I think, is the, if I understand the MCTS setup. Description is just not helping me. Nor is their code. Oh, I think they don't actually have a policy. I think they have, okay. I don't think they have a policy network. Is this? Huh. Do you actually maintain a queue function here? Random rollouts for evaluation. Okay, this I understand. Yeah, we're kind of our bet. I mean, I could technically try this. The thing is, I know for a fact this paper is bullshit. At least, like, the reasoning in most of it is bullshit. I mean, I could very easily. Do you know exactly why? I mean, we ran 20,800 hours worth of ablations on that thing. We've got a pretty good idea, I'd say. Mm-hmm. I mean, I could add in like the auxiliary planning here. Thing is, I mean, I could try. It's tough because I've been bitten so badly by this paper, right? Like the result is very good, but this absolutely should not have been published with the way that it is, because it's like half the paper is wrong. It is actually a decent baseline though, because it's way simpler to implement. Specifically, what part? I know that all the little tricks that they add, like the little tricks that they proposed, are essentially just like random, clever sounding things applied to reinforce because they didn't have a strong baseline. What's the advantage of off policy besides experience replay? That's the advantage, and that's a very important one. In my mind, it makes sense that search works. It doesn't. In my mind, it doesn't even make sense that this necessarily works. Yeah, like all this crap is wrong. Um, yeah, the problem bet is search is like monstrously complicated to implement. Experience replay, same end, work for different agents. I don't know what you mean by that. Yes, it does work for numems greater than 1. But he asks for different agents, not different envs. So presumably it's something different that he wanted. Dreamer V3. Well, that and Efficient Zero. I actually like the formulation in Efficient Zero a lot more. It makes sense to me that it works. I think it's backed by a lot more as well. It's just horrendously complicated. Because making search efficient with, like, batched reinforcement learning is not easy. I mean, search on its own is, like, already kind of non-trivial to implement. Like, in a good MCTS. It wouldn't be that bad, honestly. But doing it in the context of neural nets is freaking hard. It's 8:49. I'm gonna pick this up tomorrow, I think. Or Monday. Sure. Okay. I've tried so many different things today. Um, this was the result of the off-pol, or the buffer. Yeah, that's tough. I know their code is slow. This does quite a bit better. We shall see, right? At the very least, we found out that there really aren't any easy wins in off-pol. The whole kind of the vast majority of the off-pol work is just super freaking cursed, honestly. Breakout is supposed to be the easy task bet. But it's kind of a mess that it's this screwy. Also, literally, I undershot when I said Puffer's 1000x faster. Like, literally, some of these off-pol methods, they're not even set up by default for batched learning. It's crazy. Or at least batched inference. You'd literally be faster on CPU under that setup for, like, small networks. Crazy. Okay, though. It's almost 6. I am hungry. I gotta get food. I'm going running tomorrow. And get myself situated. And then I will be back on Monday. I'm going to try to allocate as much of next week as possible to working on all this stuff. We shall see. Now, this really friggin' bothers me, though. The fact that this is even, like, possible that this works is just, that really bothers me. Expert recording. Yeah, that works. That's super easy bet. Data. Yeah, but it shouldn't be worse than on policy is the thing. Well, okay, folks. For those of you who've spent Saturday watching me bang my head against all this research, I did a lot of different things today. Thank you for tuning in. Everything I do is right here at puffer.ai. Free. It's open source. Start the repo. Helps me out a ton. If you want to get involved, Discord, right here. Other than that, you can follow me on X for more reinforcement learning content. Whole bunch of articles here for beginners. Click the follow button wherever that is. All right.